For this video lecture, we're going to talk about two things. First is the kinetic theory of gases, and then we're going to talk briefly about some properties of gases. So there's four parts to kinetic theory of gases. I'm going to go through each of the four, and while I go through them, I'm also going to introduce you to some units that are associated with some variables pertaining to gases that will set you up for gas laws and the calculations that come with them. So the first part of kinetic theory says that gases are composed of tiny particles that are separated by large distances. So if this is my container and it contains a gas of some sort, the particles, like the actual gas particles, are so tiny compared to the amount of space between them that basically the volume of the gas particles is like nothing. When we talk about volume, right, like if I talk about like this is my container has a volume to it, and the gas, hopefully you remember, takes up the entire volume of my container. That's from physical science, if you don't remember that. Volume is a variable that pertains to gases. If we know the volume of the container, that's also the volume of the gas, because gases take up the space that they're in. So units that are going to be seen for volume when we get into calculations later: milliliters, liters, and then any unit cubed. Those are all going to be units for volume. So when I say a unit cubed, like cubic centimeters, cubic decimeters, cubic meters, those are going to be units for volume. Typically, liters is the one that we use. The second part of kinetic theory says that gas particles are constantly moving, experiencing collisions with other gas particles and the walls of their container. When we learned kinetic theory in physical science, that was what we learned, that particles are constantly moving, except at absolute zero where they don't move. Something that pertains strictly to gases is something called pressure. Pressure is the force exerted by gas particles colliding with the walls of the container that they are in. So when we measure the pressure of something like tire pressure or the pressure inside of a balloon, really what we're measuring is how many gas particles are hitting the sides of the container. The more collisions that are happening with the walls of the container, the higher the measured pressure is going to be. So I want you to keep that in mind as we get into gas laws. We'll discuss this again, but that's what pressure means. So since pressure is very unique to gases, there's a ton of different units that you might see for measuring pressure of gases. So PA is pascals. kPa, which is a fairly popular one that you might see more often than the others, is kilopascals. Torr is torr. ATM is another popular one that stands for atmospheres. mmHg is millimeters of mercury. That one's also fairly popular to use. And then pounds per square inch, that would be one that's a little more popular, especially in America when we use pounds and inches. But the most popular ones are probably going to be kilopascals, atmospheres, millimeters of mercury in chemistry. As you get into AP, torr will become more popular. We typically don't measure pressure in just pascals. We measure it in kilopascals. The third part of kinetic theory says that the velocity of gas particles is related to the gas's temperature, meaning as we heat up a gas, as the temperature increases, the speed of the gas particles is also going to increase. So we'll bring this back up when we get into the gas laws. but makes sense, right? As we heat up particles, they'll move faster. Same with gases. The fourth part of kinetic theory says that gas particles do not feel any forces of attraction or repulsion with each other. Meaning, gas particles, they move the fastest out of all the states of matter, right? So they're moving way too fast, and there's so much space between them, like the first part of kinetic theory said, that there's no way for IMFs to form between them because they just don't interact with each other long enough to form IMFs. When you get into AP Chem, we can talk about the relationship between IMFs and gases and how it changes a gas from being something called ideal to real, but for now, I'm just kind of front loading you with the basics of gases. So for now, IMFs do not form between gases. There's a bunch of different properties of gases, but I'm just going to talk about one of them, which is compressibility. So remember that gases, when you put them into a container, the gas will take up the entire space of the container. And that leaves these large spaces between the gas particles. So if you were to compress the gas, meaning you lower the volume in the container, I'm going to push this lid down, forcing the particles to get closer together. Gases can do that. Gases can compress. You can lower this lid and it's fine. The gases will get closer, the gas particles will get closer together, everything will be fine. Because of that extra space between the particles, it allows the particles to move closer together if the container they're in were to shrink. So that's called compressibility. Solids are not compressible because there is no space between the particles, so how are you going to push them to be closer together? You can't. Liquids are considered to be hardly compressible. You can compress it, but in a very small amount, because there is some space between the particles, but there's not nearly as much as there is between gas particles. So you could compress water, but it's going to be nothing compared to the way that you can compress air. Okay, so that's the one property I want you to know about gases. You can push the particles closer together because of the large spaces that exist between the particles. You can't do that with solids and liquids. And that's going to be it for this video.